Okay, now let's talk a little bit about security. We're going to talk a little bit about our secure remote access. Before we configure SSH, which is the more secure way to get to our switch, it provides our secure or an encrypted management connection to our remote device. It is replacing Telnet for management connections. Telnet is an older protocol, but it uses an insecure plain text transmission. And we can see here how that would open up our switch to vulnerabilities. Here we've got a Wireshark capture that is going on for a Telnet stream. And the person can get our username and our password directly from this Telnet section. Now, if they're using Wireshark on the SSH capture, what they get is a bunch of gobbledygook because it's encrypted. And you need to make sure that your switch is able to run SSH. From the prompt, we're going to do show version, and on this particular one it's showing that it's the K9. Let's look and see what our particular one has. We are using K9. Okay, so we should be good in our labs in order to run the SSH. Here are the steps that we need to take. You need to verify SSH support on your device, and you can do that with show IP SSH. So let's do show IP SSH to see if it's enabled, and it says SSH is enabled. We have version 1.99. So we use this command to verify that the switch supports SSH. If the switch is not running an iOS that supports the crypto feature, this command is unrecognized, and it would come back that it was either ambiguous or an unrecognized command. Next, you need to configure the IP domain, and that's the name of the network using the IP. And we do IP domain name, and you give it the domain name. Here in this example, we have configure terminal. We say IP domain name, and on this example, we're going to use cisco.com. We configure the domain in this fashion. It gives another level of our security. Then we're going to generate what is called the RSA key pairs, so that we have two pieces of our key, and it makes it a little bit more secure. Not all versions of our iOS default to SSH version 2. Keep in mind that we're running 1.99 on our switches, and SSH version 1 has known security flaws, so just keep that in mind. To configure SSH version 2, we issue the IP SSH version 2 global configuration mode command. That is this command here in order to turn it on. Then we use the crypto key generator RSA global configuration mode in the SSH server to get our pair of keys generated. To delete the RSA key pair, we would use the crypto key 0 IZE RSA global configuration mode command. After the RSA key pair is deleted, then the SSH server is automatically disabled. Next, you'll configure your user authentication with your username and your password, and then you'll configure your VTY lines, and you'll enable SSH version 2. Okay. Here again, it's going to allow you to practice what we just went over. On a PC running PuTTY, you'll go into SSH this way, and it looks like this. Very similar to the way I'm running it here. And again, you can do the show IP SSH to see what is running on your device. Keep in mind that our basic switch security isn't going to stop malicious attacks. It's just one of the layers that we use to keep our systems secure. We have different types of attacks that can go on. There is MAC address flooding, and this is where the MAC address table in a switch contains our MAC addresses associated with each physical port and our VLANs. And when a layer 2 switch receives a frame, the switch looks in the MAC address table for the destination MAC address. And our Catalyst switching modes use the MAC address table for layer 2 switching. And as these frames arrive on the switch ports, the source MAC address tables are recorded, so it's creating our MAC address table. The MAC address flooding behavior of a switch for unknown addresses can be used to attack our switch. This type of attack is called a MAC address table overflow attack, and it's sometimes referred to as MAC flooding attacks and CAM table overflow attacks. The figure to the right here shows how this type of attack works. Okay, so it's filling up our address tables. Here, our host B receives the frame and sends a reply to host A, and the switch then learns that the MAC address table of B is located on port 2. Then host C also receives a frame from A to B, but because the destination MAC of the frame is host B, C is going to drop it. Okay, now in figure 3 here, any frame sent by host A or any other host to host B is forwarded to port 2 of the switch and not broadcast once it's learned it. Okay? With our flooding, an attacker at host C can send frames with fake randomly generated source and destination MAC addresses, and it kind of floods everything up. It randomly generates the source and destination MAC addresses to that switch, and the switch updates the MAC table with the information in the fake frames. When the MAC address table is full of fake MAC addresses, the switch enters into what is known as a fail open mode. In this mode, the switch broadcasts all frames to all machines on the network as a result. So it just kind of sends it all out there at once because it's overflowing with information. Okay? One of our ways to mitigate this MAC address table overflow is to configure port security. Next, we have Dhcp spoofing and starvation attacks. With Dhcp is the protocol that automatically assigns a host a valid IP address out of our Dhcp pool. And when the Dhcp has been in use for nearly as long as our TCP IP has been in use, so it's fairly stable, it's been out there a while. Two types of our DHCP attacks performed against the switch networks, like I said, are the starvation attacks or our spoofing. With our starvation attacks, an attack floods our DHCP server with requests to use up all the available IP addresses that the DHCP server can issue. And once all the IP addresses are issued, the server cannot issue any more addresses, and the situation produces a DOS attack as new clients cannot obtain network access. With our DOS attack, it's any attack that's used to overload a specific device and denying service to that particular device. With DHCP spoofing attacks, an attacker configures a fake DHCP server on the network to issue DHCP addresses to clients. So it's not really there, it's just pretending to be there. The normal reason for this attack is to force the clients to use false domain name system or DNS or our Windows Internet Naming System servers to make the clients use the attacker or a machine under the control of the attacker as their default gateway. We have the Cisco Discovery Protocol, and it's a proprietary protocol that all Cisco devices can be configured to use. CDP discovers other Cisco devices that are directly connected, which allows our devices to auto-configure their connections. In some cases, this simplifies configuration and connectivity. By default, most of our Cisco routers and switches have CDP enabled on all the ports. CDP does contain information about the device, such as our IP address, our software version, our platform capabilities, and our native VLAN. We can have Telnet attacks, and the Telnet protocol is insecure and can be used as an attacker to gain remote access to our Cisco network device. And there are tools available that allow an attacker to launch a brute force attack through our Telnet attacks. And these we have brute force password attacks. And the first phrase of the brute force password attack starts with the attacker using a list of commonly known passwords. This is why it's important to have your password rules set up that make it your passwords difficult to guess. We can have our Telnet denial of service attacks. With our vulnerabilities in the Telnet service that permit denial of service attacks to occur are usually addressed in the security patches that are included in newer Cisco iOS versions. It's best practice to use SSH rather than Telnet for our remote management of our connections just because it's more secure. Here's one of the study aids that you can use. I suggest you use these. Next, we can look at security best practices. What are you going to have in place to keep your system secure? And defending your network against attack requires vigilance and education. Some of the things you need to look at. You need to have things in writing. How are you going to handle things? How are you going to handle passwords? How often do your passwords need to be re-entered? How often do you need to come up with new passwords? You need to have password protect sensitive data. You need to have your antivirus in. You need to keep your patches installed and updated. And then you need to also control physical access to your devices. Network security tools help a network administrator test our network for weaknesses. So we need to look into what is our network security? What are our firewalls? What intrusion prevention systems do we have? What operating system? Because some of our operating systems have known errors in them. And then what networking protocols are you using with your system? Some of the network security tools that we can use is we can have a network security audit. This allows our network administrators to perform a security audit on our system. Let's see how we can get into it. Where are we vulnerable for attacks? Is there a loophole? Is there an easy way in? One of the things that we can do is we can disable unused ports. If the ports are up and running, then anyone can get into them. So it's a good idea to go ahead and disable our ports. Let's look again here and let's do our show IP INT brief. Look at our ports. We can do our show run. There's our crypto keys. And we see our interfaces. We can go in and do config T, and we can do a range of ports. If I can remember how to key it in. Try INT range. I'll get it here in a second. I don't do this one often. There we go. And then we will say shut down. Okay, and it shuts down any port, there it goes, that may be up. As long as it's up, people can get into it. So it's a good idea to shut down our ports. And you'll see now they are administratively down. So I've shut those down. We have DHCP snooping. With our Cisco, Catalyst is a feature that determines which switch ports can respond to DHCP requests. And these ports are identified as trusted and untrusted. Our trusted ports can source all DHCP messages. Untrusted ports can source requests only. Okay, so the trusted ports host DHCP servers or can be an uplink toward a DHCP server. So some of the steps that we need to take to configure DHCP snooping on our switch is we're going to enable our DHCP snooping using IP DHCP snooping. Okay, and then we're going to enable DHCP snooping on a specific VLAN. And we can define ports as trusted at the interface level by defining trusted ports using the IP DHCP snooping trust command. Okay, here's an example of how we do that. Other ways with port security is all switch ports or our interfaces should be secured before the switch is deployed for production. And one way to secure our ports is by implementing a feature called port security. Port security is going to limit the number of valid MAC addresses allowed on a port. And the MAC address of legitimate devices are allowed access while other MAC addresses are denied access. The port security can be configured to allow one or more MAC addresses. You just need to make sure that you get this done correctly, because if a device with an unknown MAC address attempts to access that port, it's going to shut that port down. We have what's called sticky secure MAC addresses, and to configure an interface to convert dynamically learned MAC addresses to sticky secure addresses and then add them to the running configuration, you have to enable sticky. So that's a command that you're going to use. It's called switch port security MAC address sticky. Okay. And you'll get in the habit of doing this. The labs that you do in this particular chapter are going to have you do this repeatedly. You can always do your labs more than once. If you feel like you need practice, I would highly recommend that you do them more than once. It's a security violation when either of these situations occur. When the maximum number of secure MAC addresses have been added to an address table for that interface and a station whose MAC address is not in the address table attempts to access the interface, or an address learned or configured on one secure interface is seen on another secure interface in the same VLAN. Okay, so these are some security violations. An interface can be configured for one of three violation modes. We have protect, restrict, and shut down. Okay, and that tells you how you're going to handle when that device with the MAC address that's not known hits your device. And this is part of your security policies that you have in place. Here in Figure 1 is just a summarization of our default port security configurations on our switch. Figure 2 here shows you the Cisco command lines that are needed to configure port security on the fast Ethernet. On this particular instance, it's on port 18 on switch 1. And you'll notice that the example does not specify a violation mode. The violation mode is shut down, the default mode. And then here in sample 3, it's how to enable sticky secure MAC address for port security, and this one is doing it on port 19 of switch 1. As we stated earlier, the maximum number of security MAC addresses can be manually configured. So on this one, we've got switch port security maximum 50. We've got enable port security on the interface, and we've set the interface mode to access. Then we also enable our sticky learning. Okay? And the violation mode is set to shut down by default. So we've just left our defaults here. After you've configured your port security, you need to verify that you've actually done it. You can do show port security interface on the particular interface that you've done this on. Here is showing sticky when we showed our port security. We can do show run, and it shows that you've set up your switch port security. Or you can do show port security address, and that shows you your MAC addresses. This one's dynamic, and this one was obtained with this is the sticky. When a port's configured with port security, a violation can cause the port to become error disabled. And when a port is error disabled, it's effectively shut down with no traffic sent, and a series of port security related messages display on your console. So you know that this has happened. It's not going to happen and then you not know about it as the network administrator. Here's our port status. You'll see that we're disabled. Here our interface, we shut it down. Then we do the no shutdown to bring it back up. Once you've corrected the errors, there are other things that you can do. You can have the correct time within your network's important. You can correct the timestamps, are sometimes required. Things do lose time. You have your network time protocol, and it's a protocol that's used to synchronize your clocks on your computer systems over a packet switched variable latency data networks. You use Ntp, and that allows your network devices to synchronize their time settings with an Ntp server. Here's a good example of how to do that. You can do show Ntp Associations, and it shows you what it's associated to. You can also do show Ntp status. Then you'll need to complete all the packet tracer and labs for this unit, and contact me if you have any questions.